customers need. So, Lee Funnell.
Morning, afternoon. I'm not sure of the time. Can you hear me? Okay. I'd like to thank Adam because Adam, I haven't got a clue what you were talking about. I've never heard containerization. To me, that's a data center, and dockets. Isn't that something for work orders? So this is a very different world for me because I come very much from an infrastructure point of view, and now I'm learning that there's now two types of infrastructure. There's the one that I understand, which is physical, and now there's an active infrastructure. So it's all new for me. So if I apologise if we go off on track. My name's Lee Funnell. I work for the Siemon. We are the world's oldest telecommunications company. Everybody normally laughs at that. We were supplying AT&T before they were AT&T. So we started manufacturing telecommunication products back in 1906, formed as a company in 1903. So we've gone on a pretty long distance since then. When I don't work for Siemon or I take my Siemon hat off, I sit on the British Standards Institute. I sit on one of the Premises Cabling Experts panel. If anybody's involved in the data centre, I'm one of the Data Centre Alliance technical directors, very much looking at copper and fibre infrastructure. And I'm also a director of the Fibre Optics Industry Association. And if I've got a little bit of time left, I work in what we call the intelligent building market. And the intelligent building market is now talking about convergence. But you're talking about convergence in a different way to how we talk about convergence. Convergence to us is about now delivering applications and services over power over Ethernet. So we're now converging more and more systems to be more energy efficient over your current infrastructure. And I don't want to say just over your current infrastructure because there are changes that you have to make. So if anybody wants to talk about that, I'm really happy to talk about it, but that's not the point for today. So what I wanted to talk about was the growing world of internet-based communication, because that's the real driver for the amount of information that we're using today, the driver for more and more storage and where we're going to put it. But not just that, how quickly are we going to be able to transmit it and running out of bandwidth. And running out of bandwidth is a real issue for most of us, I would imagine. Or have you got loads of bandwidth? No, good. Right, one person give me an answer. So we're talking about the changing world of fibre, getting it right in your data centre. A lot of people make a lot of mistakes with fibre optics because they just think it's glass and we can do what we want. All of your systems from either Cisco will have application-dependent performance figures. And when we read a lot of specifications that come out from universities, it just says fibre. It doesn't take into account what you're actually trying to be able to deliver. And then you get that little situation where you say, my system doesn't work the way I intended it to. And we've got to go back to your specifications to make sure that they're correct. And then I just want to try and, very quickly, just try and show you a way that potentially you could save some money. Just by changing your approach to your infrastructure. And I am talking about now the infrastructure of your active equipment and the infrastructure of your passive. Right, so I'm going to try and merge those two together. Now, normally when I talk at a UCISA event, they only tell me I've got 20 minutes, and I normally take about 35. So I've got a 20-minute timer up there just to help sort of keep me. And so if you could just keep glaring at me, I'll be grateful. So what I really wanted to do was really talk about the first sort of data centres and just very quickly how we've evolved. Some of us may remember the 1960s sort of data centres, how they were. Really they were numerator systems, you know, punch cards, and we would take punch cards, store that data, and these were massive rooms, some of these units, you know, weighing up to 30 tons. But that was really the first storage of data that we really had, and that was driven particularly from the US. The American Airlines were a massive exponent in that type of technology. But luckily we moved on, because in the 1970s technology took a tremendous leap forward in what we were able to do. 1971, Intel released what they called the first commercial microprocessor, so that was pretty good. And in 1973, we actually saw data centers starting to be formed in the US. There was a book written, it's called The Big Switch. I think that was written in about 1984, and sorry, it was referencing a topic in 1984 about seeing one of the first cloud data centers. You know, and everybody coming to use that data center because nobody actually had microprocessing at their own level. So everything was being outsourced to the cloud. So going back to what Adam said, I think he was talking about things going around in circles. You know, we were there many, many years ago. So as we started to do, the computer industry started to explode. We had the IBM launch with their range of personal computers. Everybody then started seeing desktops appearing on their computers or in their desk environments. And then we started getting to this point now where we really needed now to start thinking about storage and where we're going to put all of this information. So really the age for the data center somewhat returned because we started taking care of our own data. And then it went slightly wrong, because we had lots of people who invested in IBM with the AS400 sort of systems. Anybody here remember that? Well done. Congratulations. Thank you. Have you got rid of them? Yeah, they were nice. I mean, they're nice bits. They still sell them if you're interested. So we then start moving in. So we got microcomputers into the 1990s. Started in homes really to find computer rooms. We started seeing computer rooms being developed. And a computer room was just a switching station. I want to use the word hub for want of a better word. And then we started moving into storage. So we started seeing really the birth of the data center really with the dot-com industry as we started moving forward, storing more and more data. And we started seeing a need for more and more data developing. But we started running into a bit of a problem. Power. We're running out of power. The Dutch economy, or the Dutch have worked out that the UK economy, and just powering our data centre, we use equivalent amount of power as every residential home in Holland. So we're using huge amounts of data. More and more people are now, power, more and more people are now trying to find ways to consolidate, reduce power, and make things more efficient. In our type of infrastructure, we're developing systems now with switch manufacturers on what we call energy efficient Ethernet. So some of you might have in data centers, you might have links from active equipment to active equipment, and you might be reaching distances of 50, 60, 70 meters. We're now trying to get everybody to design sub 30 meters because your switches are actually going to use energy efficiency back off. They're actually going to be saying to the other device, hello, how far away are you? How much do I have to shout to get this to you? Oh, you're very close. I can use less energy. Switches are now becoming more intelligent because they're now understanding if they're not actually needed to send anything, they just go into power save mode. Optical switches don't. Optical switches just like to scream and shout all day long, 24/7. That's the way that they try to do it. So we've suddenly seen now the birth of cloud computing, people trying to find different ways of moving it. Lots of people have moved services outside of their own environment. Some companies have decided to create their own cloud environments, and some organizations have a mix and match of the two. So, storage speeds, and you probably know this stuff anyway, you've all read it. You know, storage growth is expected to grow at 40 to 50% a year. IP traffic is growing, again, at a staggering rate. Server growth is expected to grow tenfold over the next 10 years. What we're really seeing is this whole impact of data storage. Now, the bit that I want to get back to is your switches and your servers. I don't understand any of those bits of electronics. What I'm actually interested in is the physical highway. Has anybody here ever been to Guernsey? 1, 2, 3. And if you've got lots of money, that's where you go, isn't it, to retire? Because you want to retire to Guernsey. You want to get your Porsche 911. You want to get your Ferrari. You want to get the best potential switch or server that you can, and then you can take it over to Guernsey, and the speed limit on Guernsey is 30 miles an hour. And what we're actually finding is lots of companies and lots of universities, they're making a large investment into their active electronics to be able to transmit data, but guess what? They've got a road like Guernsey. They're not able to support what they've got today, let alone in 2, 3, 4, 5 years' time, because the migration of technology is continually evolving. So one of the things that we've got to try and do is not go into Guernsey on a 30-mile-an-hour road. We actually need to get into the fastest racetrack that we possibly can. And we only want to install it once. We see lots of people out there where they're installing their infrastructure and they're ripping it after 2 to 3 years. And the only reason that they're doing that is because they've gone on price, or they've looked at a cheaper potential option based on technology, and then they've upgraded their switches, and then they find out nothing works on what they've already just installed, so they've got to rip it out. Anybody installing, can I just ask, Category 6 at the moment? Excellent. Everybody with their hands up for Category 6, do you install wireless LAN activity? It won't work on Category 6. The new generation of wireless LAN activity is going to be up to around about 2.5 gigabits for your wireless network. So you're installing a link that's only going to push up to about 1,000 base T. So you've actually got to install a 10 gigabit link to your wireless access points. But the beauty of it is, to make it work, you need two 10 gigabit links to be able to make it work. And I'll talk to someone offline if you want to talk about that, because that's not what we're here to talk about today. So data's increasing. We've got 1 gigabit of data. I think there was something saying about 10 gigabit data is like about 51 hours of Skype calls. Anybody use Skype? Yeah, I use it all the time. So we're storing all of that information. It's going up. Anybody got children? Yeah. I've got no bandwidth at home because my children take it all. Thank you. Yeah. So we're running out of stuff. And then I started trying to think about my children. And I'm trying to think about what do my children do, you know, in a few minutes of their life. And one of my daughters is constantly on YouTube. And then we actually started realizing that YouTube are dealing with something in about 72 hours worth of new video in a minute being uploaded to their servers. So from their data center point of view, they're pretty huge. What about Google? Is that 4 million? Is it 4 million? A second, or is it a minute? It's a minute. 4 million a minute. Now, one of the interesting things was when we actually started looking at Google, I think it was about 1998, they were getting something in the region of about 1,000 hits a month. You know, they are into billions of hits now. And if you'd actually look at Google, and I suggest that you do, next time that you type in or whatever your search is, just have a little look, because Google do something really clever. They actually tell you how good they are, because they will tell you, I've come back with 43,000 hits on fastest driving roads in Guernsey in 0.34 of a second. Yeah, and this is about high-speed data transfer. Anybody here remember the days of a ZX Spectrum? No, I shouldn't say it. Anybody remember back into the days of a modem, where you would sit at home and you would type in something and wait for the internet, and you would just sit there, waiting for that page to download? And that's because of the active equipment and the way that we will be able to transport that data. Look at BT now. BT's delivering you broadband to your home, so you've got high-speed data transfer. Because we now live in this world, do we not, where we hit go, or click, or whatever, and if it's not there in about 2 seconds, we start doing this. If it's not there in about 10 seconds, we're phoning up you guys saying your network's slow. Yeah? And it's all to do with this data transfer. And I really want to try and get this across. Stanford University found that the whole of the humanity produces 1.2 exabytes of data every year. Now, I've tried to work out what that is, because that's a number I've never even heard of, exabytes. Is any university here storing an exabyte of data? No? Yes? I hope not. But this is the interesting thing. That's 80.53 billion 16 gigabit iPhones, just to give you an idea of storage capability. If you're into 32 gig, you've got 32 billion iPads there. And if you've got one of those really nice little flash 64 gig hard drives out there, yeah, you need a few of those to be able to store this amount of data. And if you're into 2 terabyte hard drives, there's 629 million. Now, the reality is that's sort of up to now. Next year, it's going to be even bigger. And that's really where we need to be. So global Ethernet traffic, and this came from Cisco, who are at the back, so thank you, Cisco, for your research. They're actually talking about 1 trillion gigabits by 2017. This isn't existing data. This is new data. Yeah? And I want to get that across. This is new data. So your transport system has got to grow. It's got to keep up. You're definitely doing with all your active electronics, but I'm just wondering if we're sort of there where we need to be. So the changing world of a data center. I don't care really whether it's a cloud or not. It's about how we transmit that data and how you get it up to the cloud, how you get it down from the cloud, how you move that data around. We are trying to see the data center to be run more efficiently. We are seeing data centers changing now, where a data center is now more 70% fiber optics, and the remaining 30% on copper sort of based systems. Fiber channel, 32 gigabit speeds in 2016, but we've already now delivering 10G base T on copper. Now, does anybody know how fast 10G base T is? How fast is 10 gigabit? Any ideas? Has anybody seen, I don't know, I'll do it badly. Has anybody seen Lord of the Rings 1? There's a couple of heads. Anybody seen Lord of the Rings 2? Anybody ever seen Lord of the Rings 3? So we've done the whole thing. There's a shake of the head there. You gave up after 2. Right, I don't blame you. Now, if you want to go at home and you think, I want to go on Apple and I want to download Lord of the Rings 1, 2 and 3 all at the same time, how long is it going to take you? 40 minutes a movie? Yeah? Could it? You're going to be able to transmit this on existing copper-based systems today in around about 2.4 seconds. And we already know that that's not quick enough, because we know that your networks are actually asking for more. So if you're sitting on, let's say, a Category 6 network, which is absolutely fine, you massively reduce where you're going to be specifically in the next 2 to 3 years. We've got 40G base SR, short reach fibre, 40 gigabit base networks. We are currently developing 8 strands of fibre, so we're reducing the amount of fibre that you need to be able to deliver these solutions. Has anybody heard of something called MTP? One, lovely, thank you very much. Anybody heard of an LC optical connector? Right, there we go. It's the next generation on, because we're going to be literally pulling these MTP connectors directly into your active equipment. So you're going to be able to deliver 40 and 100 gigabit and beyond in the next couple of years. So trying to get some of this design infrastructure now, we've got to try and get it right. And we're up to 100 base now on short reach as well. So what we're just currently, to give you a quick idea of what's being developed at the moment, just talking about copper just for a second, is 40 gigabit Ethernet on a copper cable. So this will have an RJ45 at one end, and it's not going to be for the desk environment. It's going to be definitely for the data center. I don't think anybody's computer could support 40 gigabit. I think most of them are, you know, happy around 100 or 1,000 base too. So that's going to be coming out very, very soon. This cable is going to be literally there to support a 2 gigahertz connection, and it will have a maximum reach of 30 meters. One of the reasons why we put that maximum distance into the standard is because we want to ensure that you get power efficiency. Yeah? So all of this is sort of, you know, trying to save you money and to speed up the amount of data that you're going to get. Now, there's going to be 2 types of this solution. There's going to be a Type 1 and a Type 2, just to bore people. Type 1 is the standard RJ45, and Type 2 will be a higher speed connector, something which we call the Siemon Terra connector. Just so you're clear, Adam again was talking about security. We tend to now only use shielded cables. Any of you guys here now use shielded cables? How many of you use UTP? More people use UTP. Okay, higher speed performance is now only going to be on shielded cables, because we have things like EMC emissions that we have to meet. These cables are now such high frequency, they can radiate signal, you can lose data. So we now have to find a way to keep that data contained within the cable. Our cables particularly are what they call Tempest rated, so they're secret government squirrel, because they don't radiate any signal and they don't allow any crossference of any other signal to come onto those cables. So let's get onto the fibre. Now, has anybody ever seen anything like this before? No. No, there's one. That's good. Thank you, sir. Thank you very much. Because when you actually start looking at your Cisco magazine or your Cisco catalogue or your Cisco switch, when you start reading through it, it says, if you want this application to work, I must have an optical loss better than this figure. Yeah. Now, what you're going to do is you're going to go away then to your design company. You're going to say, I need fibre optics run between this building and this building. I can't run that cable now inside a building because the fire regulations say I can't, so I've got to break that fibre cable out. I've then got to change it onto a different type of fibre, and I've got to do all these variations to get from one telecommunications area to another, or from one data centre to another. But you've got a thing called optical loss. And if we actually exceed these numbers, what's actually going to happen is your fibre system won't work. And then you've got a major problem. I've recently heard of a customer who wanted to install a 40 gigabit based solution for fibre, and he installed a very old type of fibre that we don't historically sell now, which was what we called OM1 and OM2, because the rest of his campus uses it. So he said, I want to keep everything the same. And then he phoned me up and he said, well, it doesn't work. And I said, well, I've got to try and educate you on why it didn't, and thank you for investing all of that money with that other manufacturer and now having to rip it all out and start again. So there's 2 big things at the moment. There's a thing called OM3 and there's a thing called OM4. They are both exactly the same fibre. Everybody will have a heart attack at me saying it. OM4 is just tested to a slightly higher level. It's the more pure of the OM3 that comes off. This means that we can be delivering things like 40 gigabit up to either 100 meters or 150 meters over your network. Many people will try and push you down an IM4 route because it costs more, but if you're actually talking about your data center environment between your cabinets, you might only have a 20 or a 30 meter link. So if you're only going to have a 20 or a 30 meter link, just by staying on, say, something like IM3, you're already going to save 30% on that installation cost and purchase cost, because you're not going to need the higher distance that that fibre can give you. If you're going to be installing between buildings, then you obviously are going to use it. I won't particularly talk about OS1 or OS2, which are the single-mode fibres. But these figures are incredibly important. So what I wanted to try and do, I'll forget about these figures for a second, is typical losses don't actually work. Because what's going to happen is you're going to read your documentation from Cisco. That documentation from Cisco says I have to have a loss like this. You talk to your partner who deals with your infrastructure, and you say, this is, sorry, there we go, he's written it. And he's going to say, I need to get an optical loss of X, Y, and Z. And that's really where we want to be. And the trouble is, those two will never actually meet, and nothing's ever going to work. So to give you an idea, this is like a typical design. So we have an optical loss there for every cassette. So if I just take in the optical loss there is 1 dB. Yeah? Right? I've got a maximum to work with my Cisco equipment of either 1.5 or 1.9 dB. I've then got to put in my MTPs. I've got another loss there of 1.6 dB. I've then got my fibre cable. That has a loss. So I've got a total loss of 3.5 dB. 3 dB means I've just lost 50% of my signal, so my signal is not working. The application won't work. So if I'm trying to work, say even for example 10G base SR, just 10 gigabit, I know that this system isn't going to work. Your system will not support the data throughput that you need. So we've really got to go back in design now and actually sit down and we'll try and work out how we're going to do it. Are we going to do it with low loss systems? If I actually take slightly better, highly tuned product, I can then start to reduce these figures so I can actually meet the target ranges of what I want. But then it gets interesting, because these figures have come from me as a manufacturer. And these are what we call worst case figures. So you actually need those figures to be better than, because we've actually got to build headroom in to make everything work. And if anybody wants to talk about design philosophies, I'm more than happy to do it. But the big issue with fibre is nobody takes this into account in as much detail as they perhaps should. I've just got literally 2 minutes, so I'm trying to get there. Okay, I said I just wanted to save you some money, and I'm going to be very, very quick about this. I've got a cabinet. Has everybody got cabinets? Have you got dual resiliency? Excellent. So you've got a couple of switches and you've got a couple of PDUs, and everybody's happy with that. So I've got a cabinet, and I'm going to put in a 48-port switch, which I'm going to buy from a switch manufacturer, because guess what? A 48-port switch is cheaper than a 24-port switch. Yeah? How many servers are you going to put into a rack? Depends on heat load and what you can actually get in and everything else. We've got to design it in. Do you opt for a 24 or a 48-port switch? You're pushed by cost, because you're going to have to go for a 48-port switches. And then how many switches do you need in the rack? Because what we start to see is really how much underutilization you have of that switch. Yeah? So if I've got here, I've got something like 10 cabinets, I've got, say, 200 ports, so everything's nice and easy. Then I start to try and lay it out into my data center. What I start working out is that in my furthest cabinet, I've got 20 ports that I'm never going to use. I'm never going to use those 20 ports because I'm full up. I'm paying for a maintenance agreement on those. I'm paying for protection on those. I'm paying for 20 ports of technology you are never going to use. I then go up to my next cabinet and exactly the same that I've got going on there. And the next cabinet, and the next cabinet, and the next cabinet. And then when I actually start to get there from my top of rack switches to my end of row, I actually find out that I've got a lot of connectivity sitting there. Anybody buy those really nice top of rack switches? No one? No one buys top of rack? Well, there's one. And you buy that really nice cord that comes down, very expensive. So perhaps an easier way is to literally remove the top of rack switches, just take your server straight into a traditional patch panel, work on your 40 gigabit Ethernet links, yeah, or onto your fibre links, and then just run it straight back to your switch. We've then just removed every top of rack switch that you need. I just want you to think about that for a second and the cost implication that that could do for you. Think about the power reduction in there. Think about your maintenance. Think about your purchasing power. To give you a quick idea, if I do 24 by 48 port switches, I have got something in the region of around 40 PDUs, and I've got over port subscription at 400 ports. If I bin that solution and we went to the really nice big Cisco switches at end of rack, what's going to happen is I'm only going to have 16 PDUs, and I guess I'm going to save you a lot of money there. I think I'm out of time. No? 2 minutes? Right. Service running top of rack. What's the cost saving here? I'm just trying to have a look. I can't see it this way round. Somebody help me out. Is that 13 million? Down to 9 million. I think these figures are slightly overinflated against me, to be honest, but this is someone else's data. Yeah. So we can actually save you enormous amounts of money. I just did a university recently in the States. We just saved them over around about $1 million on just their infrastructure. I'll leave it to you. That's all I'm going to say. I'm going to forget that now because I'll talk to you anybody here once. I'm going to forget that, and that's terrible because I'm trying to remember that 20-minute rule. Thank you, and sorry for taking up so much time.
Thank you, Lee. We are out of time for Lee, so if you've got any questions, he and a colleague are on the Siemon stand in the exhibition, and we can move straight into the next session.